All right, here's a few questions where you asked to graph some functions. And the functions have already been factored for you. So here's one, and then so I need to graph these two. So if they've already been factored for me, then really the only thing I need to know, I guess other than the zeros, is how the graph is going to look. I know if I have an x cubed that it looks like this. If it's negative x cubed, it looks like that. X to the fourth, it's got the W shape. A negative x fourth would be sort of the M shape. So I know that, but I have to figure out which of these it is. Well, when I take a look at it, I see the x's and to see how many factors of x I have. I have 1, 2, 3 factors. And this is positive, so it's going to look like that one. So now I just need to figure out what the x-intercepts are. Since the thing is factored for me already, that's fairly straightforward. So to find the x-intercepts, I can let f of x equal 0, or let y equal 0. And then, as this is already factored, I can use the 0 property that says if I multiply anything by something and it comes out to 0, then one of these three things must equal to 0. So either 3x is 0, x plus 2 is 0, or x minus 1 is 0. In the first case, dividing by 3, you get 0. Next case, subtract 2. And next case, you would add 1. Oops. So these are my three zeros, or x-intercepts of that function. So if I'm going to graph it, at 0, something happens. At -2, something happens. And at +1, something happens. So I need to impose this graph on those dots. Maybe just try and do it in your own mind and see if you'll come out okay. I would do something like this. So it has to start low and end high. So it's going to come up through here, come back down through there, and then come back up there. So that's what the graph would look like. And these are the important points: x-intercepts of -2, 0, and +1. I guess I could find another point right here to see how high up that goes. And I could do that by plugging a -1 in everywhere I see an x. Let's try that. So let's try the value of the function when you plug a -1 in. I'm thinking it'll be positive something, but let's see. So it'd be 3 times -1 times -1 plus 2 times -1 minus 1. So this would be -3. This would be a +1. And this would be a -2. So -3 times 1 is -3. -3 times -2 turns out to be a +6. So that point right there is going to be -1 and +6. And again, I could do the same thing there. I could plug in a 0.5 and see how low it goes. But that's the general shape of the function. In the second one, this next page is a second one. A similar kind of thing. I can let things equal 0 equals -x, x plus 2 squared, x minus 1 squared. Now I need to know what degree this thing is. Like, is it an x cubed or an x to the fourth or x to the fifth? So here I've got one factor. Here, oh, because this is squared, that's 2 more. So there's 1 here, 2 more there, and another 2 here. So altogether, that's an x to the fifth function. X to the fifth, similar to x cubed, start low and end high. Oh, hold on. This is negative. So instead of starting low and ending high, they start high and end low. So they'll come down, have this kind of shape to them. Okay, again, we let it equal to 0, so either -x is 0, x plus 2 is 0. There's 2 of those. Let me just put another one in there. And there's 2 of these. Okay, so divide both sides by a -1 and you still get 0. This will give me a -2, another -2, a +1, and another +1. So if I'm graphing this, something happens at 0. At -2, something special happens. and at positive 1 something special happens. So it just bumps off those parts because the multiplicity is 2. There's 2 of those. So I got to start high, so I'm going to start high, come down, and I have to bump off of this one. So I come back up, and then I come back down. I get to go through that one. But then when I come back up to go through this one, it's a double, so, or a multiplicity of 2, so it bounces back the other way. So that would be what the graph of that function would look like. Hopefully that helps you out with those two graphing polynomial questions.